Yeah, that's the
Cool.
important part. If you've all got a drink, or certainly those people that are in person down there in London. But obviously, if you're remote, then by all means, bring a pint with you. I didn't. I brought just a pint of water because otherwise I'll start talking nonsense, and you don't want that.
Oh, we like that bit.
Yeah, well, maybe next time, or maybe when it's not recorded, for posterity reasons. Hi, so I'm Pete Gallagher. I'm currently an application architect manager at Avanade. I'm also a Microsoft MVP and a Pluralsight author and public speaker, which is what I'm doing tonight. I also run a few meetup groups up here in Nottingham, including an IoT one, Knots IoT. So if you're interested, do check that one out too. I've been doing this for as long as you can see my hair is grey, a good number of years. On top of this, I'm also a STEM ambassador, and that's kind of driven by that bottom line there that I've got two inquisitive little girls who are constantly coming into my office and asking what it is that's making those strange sounds normally. So robot arms and that sort of stuff fiddling around. Sadly for me, I don't get to do a great deal of IoT in my day job. Avanade in the UK at least don't do a great deal of IoT, but this talk is reference to one of the best projects that I've been involved in, which is actually almost a year ago to the day, not far off that I was down there setting this up, and you'll be able to see what it is I'm talking about here. So what is it? The Avanade Intelligent Garden. We did this project really as a celebration. So last year was Microsoft's 50th birthday and it was Avanade's 25th birthday. And we wanted a way to be able to demonstrate that we could create projects while thinking out of the box. So this wasn't some strange cloud migration or setting up Office 365 for somebody. This needed to be something a little bit different. And so we looked at what could be done, and we'd been involved in the Chelsea Flower Show in the past at a far smaller scale, and we approached the people that we'd spoken to around that, and together between us came up with the idea of basing this around urban trees and urban environments. Now, when you look at the stats, actually, it's mind blowing that 30% of newly planted trees will die within the first year of planting, and 50% of what's left will die within 10 years. Now, that's bad. That's bad for trees. That's bad for humans. But it's also bad for the people that plant them and their pockets, because it can cost £50,000 a tree to plant a tree. And when you start thinking about urban trees, you can see why, because you can't just walk up and lift a slab and plant a tree in the middle of London. You've got to go through all of the planning permission to get that done. And then you've got to get folks involved, all of the builders, all of the architects, everybody involved to do just the planning. Then you've got to dig it up and plant the tree, and then likely you're going to need to put some form of railing around it, and then you've got to have to look after that tree afterwards. So it's a very expensive business, and the last thing you want is that tree to die during that time. Trees in urban environments have got all sorts of benefits for us humans, of course, in that we know how trees work by absorbing things like carbon dioxide from the atmosphere as well as other things, and then squirting out oxygen as a result. But also the shade it gives you, and also the benefits to mental health. There's all sorts of very good reasons to have trees in urban environments. So keeping them alive, very important. Chelsea, for those that don't know, that runs once a year. And we had at that Chelsea Flower Show 14 official show gardens down what's called Main Avenue. And this allows top garden designers from around the world to come and show off what it is that they can do. And it was amazing having been there and seen some of the gardens and the processes that they go through to create these gardens. And then there are awards for the various types of garden, and each garden can get its own award. And the best garden actually went to the garden next to us, which was like a Japanese style garden. It was incredible. It was really cool, well deserved. A really kind of tranquil place, and you could see the effort and the emotion that went into that garden. It was cool to see it being built. What was great about this, of course, to pivot off of what I said previously, we didn't just do this for fun because we could. Really, it was a big marketing exercise to a degree, but we wanted to do this in a sensible way, in a sustainable way, and one with a certain amount of motion to it as well. But of course, while we're there, we get a huge amount of coverage. So I mean, there's 145,000 people visit Chelsea Flower Show, and certainly those large gardens on Main Avenue, which we were one of, will get a large proportion of that visitor base coming along and having a look. On top of that, of course, the press side and the publicity that you get as a result of that, BBC run programs on Chelsea Flower Show every day. So if you've seen them, you'll have seen the Avanade Intelligent Garden as part of that coverage. Not only that, but of course, the King and Queen, they come and visit and have a wander around all of this, which gets a certain amount of publicity as well. So good reason for doing this. But when you combine doing it for good as well, then it sort of takes away from that business angle somewhat, which is nice. It's not just me. It wasn't just me at all. So you can see there was a whole heap of people involved in this project. It was actually 2 years in the making. It took a lot of planning to get this right, and a lot of development, a lot of design, a lot of thought, and a lot of red tape to get through, even internally, explaining to people and convincing them that this was a good idea. But it was amazing, really. And working with the folks you can see on the screen here, I was the IoT SME on this project. And I was sort of drafted in and out at various parts, but as it kind of works in consulting. But a lot of these folks were full-time on the project, and you can see certainly Devon, Martin and Steve were full-time on this project for that full 2 years. So a huge amount of kudos to everyone involved on that. Along with that, we partnered with Jayan and Tom Massey, who are themselves multiple gold winner Chelsea Flower Show show garden owners, essentially. As I say, we'd done a little bit of work with them the previous year at that water aid garden, and so we had an existing relationship with them already. So that made that job slightly easier for many different aspects. A, they knew what they were doing; they'd done it before. But B, we had a certain amount of trust in what they were doing, as they'd already won gold. Obviously, winning gold at the Chelsea Flower Show should be your ambition if you're going to go and do that. So there's multiple facets to why you want to go and do that, but winning gold really does prove the point. What was interesting in this whole process, though, of course, is that we wanted to do something slightly different. So creating the garden, which is what you can see on the right-hand side of that slide there, is just one part of it. We wanted to fit sensors into the garden and turn it into an intelligent garden, but in the right way. Now, no one had ever done this before. No one had ever brought technology into the garden before. We were the first to try and do this. So yes, it sounds really exciting. Yes, you're the first, but also you've got to try and break that ground, if you excuse the pun, in that putting technology into something like this has got to be done with a lot of care, because a lot of folks are going to deem that as a bit against the religious aspect of it almost. So these people are very serious in their views of how you should be dealing with creating certainly environments like this, never mind at Chelsea. So it needed to be done with a lot of care, a lot of sense. And Jay and Tom there were really good at doing that, because they knew the mood, they knew the feel, and what would work and what wouldn't work. And we were able to work with them as a nice synergy between creating the garden itself and then the tech that Avanade could bring to that as well. So this is what we ended up creating. This is a walkthrough of the garden. This is Main Avenue that you can see on the screen at the moment. So that's the main avenue where all the show gardens are. To the right-hand side and straight in front of the camera was the Japanese garden, bit out of shot. But here, what we've got is 12 different types of trees. So the trees really were kind of the main aspect of the garden. And each of those trees was instrumented. And I'll get to what that looks like later. That tree right in front of us, actually, that tasted of smoky bacon crisps. It was really odd. Everything in this garden you could eat, which was incredible. Even if you wanted to, this pavilion area was made out of ash, but in between the ash on the left-hand side, you can see is mycelium, mushrooms. So incredible, really. So all biodegradable in that respect. The ash was made from the dieback ash. If folks don't know, there's an issue with British ash where there's a disease affecting it. Within this pavilion, which was Sebastian Cox designed, we fitted our screens, and I'll come back to those there, but they were able to surface the data that we were collecting from those instrumented trees, as well as other parts of data as well. So that pavilion area there, this was amazing to go in. So the week that we fitted this, I don't know if you remember what May last year was like, but we had a heat wave. and it was absolutely stonking hot while we were setting this up. But you went into that pavilion area and it was constantly many degrees lower than the outside, and it was busy. You'll see on the next slide actually what this looks like. It's just a bustling area, but you go in here and everything calms down and all of the noise fades away. It was quite tranquil, and I think that's exactly what they're aiming for. So what you can't see directly here is above that there's a little oculus window even, and a roof garden, which is where, and you'll see on some slides later, where the Raspberry Pi element of this was stored. So you could actually go up on the roof and stand on it, which was quite cool. It didn't start out looking like that. Actually, it starts out looking like practically just a hole in the ground. And that's no word of a lie. What you can see there is what you start out with. So you have to strip it all back and then build everything from scratch, and afterwards set it back to the way it was. And you have to do this within a few weeks. You only get a few weeks, and then they tear it down and get next to no time to put it right. It's an incredible, almost military-esque exercise to see what they do here. So that's just the pavilion area, which most of it was constructed off-site there by Sebastian Cox, and then delivered to site. And then after that was all sort of in place, they started bringing in trees, and then started planting trees. And then after that, then they start developing. There was a stream that they put through the middle of it. It was incredible. And then all of the other flora that goes around that. It's all done with so much care, and really does show the amount of effort that goes into designing something like this. Pretty incredible. So that sort of gives you a high level of what this is about. Of course, you know, you're sitting there at a Raspberry Pi Pint meetup. You want to know about the tech. And I'll front load some of this. Actually, the Raspberry Pi part will come closer to the end. That was the part actually that I was most involved in, was the Raspberry Pi side. But as the SME, I was involved in practically everything. So what were we doing? Well, essentially, this was all built on retrieval augmented generation, or RAG. So if you've used AI recently, this is a way to be able to have AI infer over your own data. So on the left-hand side of this diagram, we consume either third-party API data. So generally this was for the weather, so we're able to embed the weather into what we were doing, or the sensors that we'd use to instrument the garden with. We ingest all of that data into Azure and then process it and store it. Once you've done that, then you can start either just surfacing the raw data, or you can ask the AI to look at that data and give you responses. On top of that, we can embed a training data set in there as well. So I mentioned there was 12 trees in the garden. Each of those trees would have a sensor fitted to it, which you'll see in a bit. But each of those trees would have different requirements. So they're going to need different levels of light, different levels of exposure to nutrients in the ground, different levels of water, all of those different things. They'll cope with different levels of lean and that sort of stuff. So we were able to, and you'll see that in a bit, talk to these individual trees and ask them how they were feeling. Essentially, it was pretty cool use of AI and RAG on top of that. Once we'd done that, then we could use either the garden screens, which were little surface tablets with the app on it, where we could hand them out to folks and they could interact with the garden that way. Or there was an actual web app that you could dial into remotely as well, and then the garden screens that you saw too. So the app itself kind of looked like this. So you went to the app and then you could start chatting. We called it Tree Talk. You could choose your tree, and then you could ask it a question. So in this case, how can I help? And then it would use that. So this is tree specific, and it would use the data that you're gathering from the tree and the nearby area, along with that training data, and then the AI model to be able to then give you a contextful response to your question, which was really good. And it was conversational as well, which had its own downsides, because you've got to be careful with jailbreaking when you have it in conversational mode. But the folks that were creating the AI elements of this did a really good job of keeping the guardrails in place. It worked really well. So you can see there that it's able to give you some idea of what it is that it's actually asking for and what it's doing. Now, if you want to, though, you can go ahead and either scan that card, or a QR code rather, or go to that URL and you can chat with the trees. Now, bear in mind that the garden is no longer there. I mentioned earlier it's torn down. The trees are somewhere else. The sensors likely have been removed from the trees and are in storage. So the results that you're going to get by doing that are likely to be a little bit odd. But nonetheless, you can have a look at the app and see how that works. That was just open to the public for folks to be able to use. That was quite fun, actually, and you'll see towards the end how fun that was. So that's cool. The pavilion screens I mentioned earlier, they allowed us to be able to. So it was sort of on a rolling screensaver type idea, the track mode, if you will. So that central area there would switch tree over a timer, and then either side of that would give you detailed information then either about the tree or the local area as well. In this particular case, it's looking at a black birch, and these are actual photos of those trees from the environment there. And then it would give you information about the lean angle and the amount of light and how much these things were growing, which was quite cool. We instrumented the garden with a whole heap of sensors, but as I've just mentioned, the trees, I'll start with those. But we really wanted a way to be able to instrument almost anything, but we needed to make sure that the data we were getting was relevant and good, and that it didn't take us years to build it. We had weeks to actually build it. Obviously, we created the sensor platform a long time before that, but you've got to go instrument the garden, and that is done in and around everybody building it. So it needed to be easy to be done. And the whole thing needed to be engaging and then relatable. As I mentioned earlier, it needed to be done with care. We didn't want to force and thrust the whole intelligence side of it onto folks. It really needed to be a garden first and then the intelligence after that. We also had a budget and also wanted to make it accessible to folks that wanted to do this themselves. So trying to use off-the-shelf components as much as possible was key to what we were doing. And we wanted to measure everything. So we needed to measure moisture, pH, all of those parts you can see on there, all the way through to how the tree actually grows. And so some of these we're able to do, and some of them just were too expensive to put in the garden. So we just didn't. pH level in the water was an example of that, in that the pH sensor was just too expensive for us to put in, to add the value that it really needed to justify the cost of going and buying that sensor. The overall solution kind of looked like this. So top left, we measure the weather. So we just pull that in for an API. We use the BBC's API for that. That was quite a fun call, actually, being on with the BBC and listening to how enthusiastic they were about their job and then the project. It was really cool to do that. Then the tree sensors, the ePlant tree sensors there. I'll explain a bit more about them shortly. And then the Raspberry Pi AI pollinator counter there in the middle left. And then all of the other sensors were based on ESP32s. Azure services in the middle here. So either going to be Azure functions, where we're talking about third-party systems, or anything we created ourselves went straight to an IoT hub. And then we go through Azure functions and we use Cosmos for the storage or blob storage, depending on what we're using. And then an Azure web app and OpenAI model to be able to do the inference. Interestingly, Dave Bostock, the guy that was one of the main creators of a lot of the sort of hobbyist style sensors there, loved Home Assistant. He had that in his house, and so he wanted to make sure that he carried on using that. So there was even Home Assistant in the garden, which is quite funny to think of Home Assistant sitting there at the Chelsea Flower Show, but nonetheless, that worked quite nicely. Instrumenting the trees, we used an ePlant tree tag here. These are LoRaWAN based devices. So you have your trees instrumented. You drill the ePlant tree sensor into the tree. That communicates to a gateway, which was behind the pavilion, and then that communicates with the rest of the LoRaWAN network, and then we can access that data through their API. Of course, you could have done this yourself to your own LoRaWAN network, Things network or something like that, but they'd already developed this system, so it just sped us up, meant that we didn't need to do any of that. Also meant that we didn't need to worry about coverage no matter what, which wasn't something we'd had much luck with actually at the garden with the ESP32s, which you'll hear about in a bit. These e-plant sensors, not only will they measure temperature and humidity, they'll also measure light level through the solar panel there. They'll also measure the lean of the tree. So if you imagine if a tree isn't rooting correctly, it will start to lean, and that's an important indicator of tree health. It's also got a dendrometer in it, which measures micrometer size growth in the tree. So trees grow from the outside out. So you drill the sensor into the tree, and then that dendrometer will be pushed back by the growth of the tree while the sensor itself is fixed internally and everything else grows out to it. So if the tree is not growing over a period of time, then it's important to recognize that. So early signs of all of those tree health will help mitigate that issue of 30% dying within the first year, hopefully, but certainly the 50% after that dying after 10 years with good planning. All of this data, of course, you can then take backwards into the arguments and the decisions that you make on which trees you plant where and for why, so that you make sure that you get the right tree in the right environment and give it the best chance of survival. So tree tags, they were really cool. But we also wanted to test things like the soil moisture and the temperature and humidity around the garden and the air quality and things like that. So, as I say, Dave Bostock, he was tasked with creating a lot of these sensors, and he did all of that in his home office and went to town on it. It was quite fun watching him go. Uh, a bunch of us were involved in that, but Dave did a bunch of the build on that. So, testament to his effort to try and do that. Um, Most of it was around what they called a GEM sensor, so a garden environment monitoring sensor, but really it was an ESP32, and then the sensors we placed around that, so either soil moisture or temperature humidity. And these things, of course, needed to be battery powered because we weren't going to run Flex around a perfectly beautiful garden, and they also needed to be small enough that you could hide them away. As I say, we wanted to do pH testing of the little stream, ephemeral stream they called it. I'm not quite sure why they called it an ephemeral stream, but there was a pump around the back of the pavilion area that would pump that stream back up again, and then it would return the water to the pump again. So it was beautiful to look at, very relaxing. But nonetheless, testing the pH of that didn't actually give us a great deal of data because it was a false environment stream, but it was just too costly to put in. And also, as it says here, we had the issue of actually affecting the results with the leaching of the metal into the water, which is not ideal. So didn't work with what we wanted it to do. As you can see, this is Dave on his way creating a whole heap of sensors on Veriboard. So this is him prototyping. And in fact, so much so that he went and bought himself a CNC milling machine. You can see in there in the bottom two videos there where I think he was using quite a lot of this as a good excuse to go and buy himself some toys. But nonetheless, he was able to etch himself the circuit boards because we weren't going to get them in time from any of the manufacturers or at the price point we wanted. If you want them from JL PCB or any of those people, it's going to take you perhaps a week to get them, and we just didn't have the time. By the time we'd finished designing them, we'd started to run out of time. So he bought a milling machine and just milled them, which was quite cool actually. Came with their own issues while he was doing that, of course. In that some of the milling was a bit inaccurate and stuff. You'll see a picture of that. These are some of the sensors after the finish being built up. So most of what you can see on the screen here are the moisture and temperature and humidity sensors that we were planting near the trees. And I like that he had banana for scale down there as well. But it really does give you an idea of the size of these things. And in fact, most of it, of course, is under the ground. Top right-hand corner there was the air quality sensor. That was the part that was connected to Home Assistant, and then in the middle here we had a shed essentially at the back of the pavilion where we fitted most of the networking for this. But also what you can see at the top of that shelving system is the drivers for those screens. So the screens needed to be cosmetically blended into the pavilion as well. Now a regular LCD will stick out quite a way, but these were pretty flush on account of all of the electronics are in those boxes, which was quite cool. I've not seen that before actually. There are 3 4K screens, and you just have a single wire that goes between them and keeps all of that nice and flush, which was quite cool. So yeah, that was that part. Some of the issues that Dave found as he was doing this as well was that things that aren't documented very well in the Wi-Fi on his ESP32C3 didn't work below 4.2 volts, even though it's documented to do so. And it took him ages to figure that out. So I don't think it was quite that it didn't work; it was that it was really flaky. So when you start driving the ESP32 with batteries, it's below that 4.2 volts. So he struggled with that. Took him quite a long time to figure that out. The other thing is that it was taking more power than it should have done as well, even though it was in deep sleep. So in the end, he ended up building a watchdog that would wake it up, and then it turned that 1 to 2 days into 4 weeks on two AA batteries, which was pretty cool. He tested that over a couple of weeks in his garden, and then I gave the first one to Tom Massey to install because it's sort of his garden. He installed it and then watered it, and then it died. So it was waterproof, as in it would sit there, and if it rained on it, it was okay. So I guess splash proof is a better way to put it, but it absolutely was not designed to be sunken into a mud pie. Which is what happened. It was quite funny listening to Dave just slap his forehead on the phone. But nonetheless, we replaced it and it was all good. That's actually Dave there. I love that photo of Dave. That sort of rounds up exactly who Dave is as a person. It kind of reminds me of Doc Brown in all the good ways. Such a good guy, so enthusiastic. And yeah, it was that's him on a table in behind the pavilion while everything's being built, soldering pieces that needed soldering on and fixing up pieces that ought not to have fallen off, stuff like that. So that was quite cool. The sensors here, you can see there that we're screwing the sensor in to the tree in the middle, and then on the left and the right, that's Tom essentially digging a little hole and sticking the soil moisture sensors into the ground there beside each of the trees, and then we combined all of that data together to be able to then reason over it with AI. So that was good fun. Now the Raspberry Pi part, which is of course half of the reason why you've come here. The reason why this existed is not just because I wanted to geek out and not just because I wanted to buy the brand new AI Hat Plus. It also is that one of the aspects of a good, healthy garden environment is the presence of insects in that garden. Now, specifically flying insects in this case. So the RHS created something called fit counting, which is flower insect timed counts. And this is something everybody can partake in. What you do is that you print off or you buy a 50 by 50 centimeter square, and you literally put that over an area of your garden, and then you sit down next to it for 10 minutes with a piece of paper, and you jot down every insect that comes and lands on that particular set of flowers that you've zoned off. Now, that's great, and a great reason for people to go outside, great reason to get involved in nature. But if you want to measure it in a reliable way, we can't have people sitting in the garden all day doing that. It's just not going to work. However fun that might be for somebody to sit there and watch the insects. So we wanted to use AI to kind of replicate that, but also take that data and use it. What was cool about that is that this whole thing ended up in the Raspberry Pi magazine, which for me, because I created it, was like a little tick box on my wish list to land in that magazine. It's here actually. And I'm quite proud of that landing in there. So that's why that gets a mention. What you can see on the left-hand side is the result of what we created. So the whole thing was based on a Raspberry Pi. And in fact, it is here. So this is one of the Raspberry Pis that was down at Chelsea. So there's just a regular camera here. So we didn't use the AI camera because we needed a bit more grunt in what we're doing. And you should see that in a bit. And then there's Raspberry Pi 5, a 16 gig one with the AI Hat Plus. So not the AI Hat 2 Plus, which is what's just come out recently. So this is, I think, 26 tops of processing power, AI processing power in there. And then that would just be pointed at a particular area, and then a lot of training done to the data to give you a model that would work on the AI kit specifically. It would then look, and I'd trained it on bees and wasps and flying insects and some butterflies as well. We didn't get many butterflies, mainly bees. And in doing so, developed my own love of bumblebees. I don't know. I was saying earlier about the people sitting there watching the 50 centimeter square. I was doing that essentially, but for a lot longer because I was watching all of these videos. But it was great to see that, and when you get it working, it was able to recognize those insects and the flowers, and then it would produce a video as a result of that. And I'll give you a demo of that in a bit. You couldn't just walk up with that pie I've shown you though and put it in the garden. Someone was not going to like that, and that someone was Tom Massey and Jay On, and quite rightly so. So everything had to fit, and it had to look like it was designed to be there. So that top left image you can see is a completed what they call bird box for my AI pie to sit in. This is actually on the roof of that pavilion that I was mentioning earlier. So in the bottom left image, you can see the pie without the box. This was one of the other pies, sees brown case rather than a silver case on this one. Beneath it is a battery because it needed to be able to sit there and work even without power. And then it took us actually just a while just to figure out what battery to use. In that most of the batteries don't power pies, or not properly, and not for long enough, and not when you've got an AI hat plugged on it for sure. The power requirements of most batteries can't cope with that. But we found one that would actually have a plug socket in it. Super useful. Certainly, as someone who goes camping relatively regularly, it was something that I actually bought for myself afterwards because you can plug what you like in it, and you know you're going to get the output, which is great. So that worked really well. On that bottom left image as well, you can just see that oculus that I was talking about. So that's the window in the roof of the pavilion you can see on the left-hand side there. So what was on the roof was a wild garden, essentially, like a meadow garden. It was designed to just be, sort of almost sort of weeds and flowering small flowers and that sort of stuff. The flowers that you can see in the bottom left image, I had Tom plant. I've got images of him sitting on the edge of the roof. I spent a lot of time on this roof, by the way, because that's where I lived, trying to get this thing to get up and running and be accurate enough to be used. But he came up and he planted those daisies in there so that I had something to focus the camera on. Which was nice. It came actually without all of that sort of weaving that you can see around it. This was designed by Sebastian Cox, so the same person that designed the pavilion area designed these boxes. And they came to site. They had two of them, so I mentioned there was two pies, one on the roof, one actually in the garden itself. And they sat there and they were threading all of that wood into that box. It was quite cool to watch. I found it. I'm a huge geek. I found it geeky. They were laughing at me because I was geeking out watching them build this thing together. And there's me looking quite proud with the finished product there on the right hand side. If anybody has tried to retrain data for the AI kit, then they might well know my pain in that although this is documented, I don't think it's documented very well even now. And it certainly wasn't documented very well then because it had only been out for a matter of weeks when we started using this. And it is not straightforward at all. It's actually straightforward to use the pre-existing models fine. So people detection, pose detection, all of that sort of stuff. You can use those models. But the reason why it's hard is, you see where it says Halo there, it requires a certain format of model, a HEF file is required, which is a Halo something file. I forget what HEF stands for. And to get there, you've got to go through a whole heap of steps. And the whole thing, as you can see on the screen, is actually iterative as well, because you've got to take what you do and then retrain it and then retrain it. And it's not fast. Now, most of what they did is working best on Linux. So I don't have a Linux machine. I've got a Windows machine. So I used Windows subsystem for Linux, WSL2 actually, to do most of this. So there's a Halo model zoo here at the bottom left. So that Halo, Onyx, and Ultralytics are part of the model zoo. But before you get to that, what you need is some training data. So it could recognize regular things, but recognizing specific insects and what they were doing, I had to retrain it. So I started just by taking lots of photos of the insects in the garden, and then you can feed them into a product called Label Studio, which allows you to be able to take those images and then draw boxes around what it is it can see and then give them labels. And then you can export that data set, and then you can leap into Docker within WSL2, I'll have you know, so it's quite Inception-like. And then you can take that training data set and retrain a base model that they give you in Ultralytics YOLO. I used V8. There's lots of different ways to do it, but I found V8 to be the most reliable. But that you can't convert straight to that HEF format. You've got to go from that to Onyx first, then from Onyx to a HEF file format. Actually, retraining the Ultralytics model was actually quite quick. Creating the Onyx and the Halo took a long time, like hours to do. And in fact, while it was doing it, for some reason, it told me it failed. So I ignored it and just tried to fix it for a number of weeks. It took me a long time. I went to MVP Summit and came back, and I brought it with me, even while I was trying to do that because of the time constraints we were under. And wasn't until I spoke to somebody at MVP Summit, and they said, "Have you actually tried that model that it says it's failed?" And I said, "Well, no." So I tried it, and it worked. So thankfully, that kind of got me out of jail because I still haven't fixed the problem. But it looks like it's not a problem. It just carries on. I learned too much about YOLO models while I was doing that, including you can visualize a YOLO model with an online tool, and you can see all of the nodes and the different parameters that it uses. And it seemed that certain models would drop the end off it, and then it would mean that it was ignored by Onyx. It wouldn't work. Oh, it was complicated. None of this is documented very well at all. So I had to discover a lot of this myself. So you go through that process, you label, you go to Docker, you retrain, you convert to Onyx, you convert that to a HEF file format. Then you have an application that you can run on the Pi that will use that HEF and the AI kit to then do inferencing, which is exactly what you have to do. And of course, it's not quite accurate enough, but it's okay. So what I had is I had it set up in this mode where it would record videos of anything that moved. In fact, anything it recognized, it would record a video, and it would produce a boxed version and an unboxed version. The unboxed version would tell me what is it that you saw, and the unboxed version I could then take and I could extract images from that and use them for training and go around the loop again and fine tune the whole thing. It took a number of weeks just to get that part working properly in my back garden. One of the biggest problems I had actually is that when we started doing this, it was May is when most of the insects start coming out, and I was doing this at the end of March. And there was next to no insects in the garden. So you only got certain types at certain times on certain days on certain flowers. So there was me going down to B&Q and buying loads of selections of flowers, which I'm not a horticulturalist. I'm not normally green-fingered, but it was quite fun nonetheless. But my wife was laughing at me, sitting in the garden, waiting for butterflies and bees to come along and then shouting when one did. So it was fun to do that nonetheless. It was good. So you do that, you retrain it, and then finally you get to a point where it works. Now, I can show you some of this. So if I go across a screen, this is Label Studio's website. So all of these links will be on the slide at the end. So don't worry about taking the URLs down. You can get this installed on Linux. You can see there, which is exactly what I did. And when you get that up and running, then you get Label Studio, and you land here. And then you can go into the project that you created here. I made sure to use 600 by 600 images because that was the format of the video that I was using. And then you can import your images and then you can label them. So each of these images you'll see, I've labeled all of the bits. Now, what you'd probably struggle to see down here is a bee. Well, actually, it's a hoverfly, but I was calling everything bees because it was just easier for the model to deal with that. And then all of the rest of these are flowers. And it was very important, of course, to make sure that you map that negative zone of all of this so that it knows what's positive. But for us, it was important because to satisfy fit counting, the insect has to land. Now, we couldn't necessarily tell if it landed, but we could tell if the boxes overlapped. So we used that to make sure that when we were sending messages about what we detected, we'd detect insects flying around, but if they overlapped, we'd set a bit that said that it has landed on that particular flower, so you could use that for your analytics, which is good. So you'll need an AI hat, so go ahead and you can have a look at the Raspberry Pi site for all of that, and they give you information here on all of the software too. I printed a case, so I definitely wasn't going to use those colours, hence the reason why I ended up with silver for one and brown for another. But again, all of these links are in there, but we just used a Thingiverse case for this that had been designed to fit with the AI hat, and this worked quite nicely for us. There's an extension version that we ended up using actually there to make sure that you could line it up with that bird box's aperture, if you remember. to go through most of this. Now, I would love, I've got a blog post here that's in draft mode and I would love to publish it. Unfortunately, nearly everything I did is under NDA as far as Avanade want to monetize everything in that garden essentially. And so everything as far as code and process is concerned, other than what I'm showing you here, is essentially under NDA because it's going to get monetized. So I'd love to be able to give you all of the code for what I've done. In fact, I got so far down that path that I published the code on the Avanade GitHub repo, and then was told to immediately take it down because there'd been another meeting that said, no, sorry, we need to monetize this, so you can't put it up. So I'm kind of gutted that I can't, but a lot of the detail is here. So this is the model zoo I was referring to earlier. Again, the link will be in the slides at the end. And this will give you the information. So here's how to retrain. And so this is where I started. This does not give you everything you need, but it does get you a good way there. On top of that, then is the YOLO retraining part here. So that will give you a good idea. See, exporting to Onyx, and then from Onyx, compiling the model to the Halo model zoo to be able to get a hef file out of it. This should get you most of the way there. But I guess if you really start doing this and you really get stuck, you might be able to drop me a message and I might be able to help you get over some of those. But I absolutely can't publish what I've done, which is a crying shame. But you never know, some point in the future, might be able to do that. I promised I'd show you how this works. So this is actually on the Pi. So I've VNC'd into the Pi. I can't SSH into it because actually it's going to pop a window up. So this is all in Python essentially. So all of the code they'll give you is in Python. So you'll see that I've sourced it. So I've got a virtual environment on the left-hand side. I can't show you the code. I'm terribly sorry, but I can show you what it does. So what's great is there's no point me trying to coax a bee in here right now. It's not going to work. But I can take one of the videos and I can feed it through that same model pipeline and have it behave as though it's coming from the camera, which is quite a great way to be able to retrain this whole system. So I don't have to wait for insects to do my bidding. I can just take one of the videos that I'd recorded already and feed that back through and have it infer over that, which is quite useful. So if I run this, it'll pop up. If I just maximize that so you can see it a little bit better. There we go. So you can see all the flowers and you can see the bee. So it's hard to see the bee, but it's in the bottom left quadrant down there in green. So each of those flowers is jiggling around and the bee is doing what bees do. Now, what this has done, because it's recognized a bee, and this is live, so this is the actual AI hat doing its bit here, and this is live inferencing over the top of that. What it's doing in the background is saving a bunch of files for that. So if I close this, and then we switch across to what I've got it set up locally here, just makes it easier. Normally that file would be sent to Azure storage and it'd be in blob storage and I'd have to download it. Painful. So I've just got it set up to save it onto a USB memory stick. But you can see what it's done here. I've got an original image. So that's just one snapshot. So you can see there's a bee. It's quite hard to say. I don't know if it'll let me zoom in. It won't. There's a bee down here. Well, it's a hoverfly, but classified as a bee. So the video has started there. It's created a single image at that point, and then it'll create a video too. So this is just a blank video of everything that's going on, so that I can take that and use that for training purposes later. No point training it on a video that's got all the boxes on it because you're training it to recognize boxes at that point, which is no good to you. You need the original video to do that. But because, of course, you're interested in what it spotted, you also export a boxed version of it, which you can see there. And then a little bit like the one at the start of my slides, there you can see just the bee, the hoverfly, yes or no, wandering around in that image. And you can see as well in brackets there, that's the percentage certainty that it is what it says it is. So one of the biggest things that you find while you're doing this is the false positives. And it really is trained for the environment. So even that's actually my back garden. That video was taken, and the flowers that were in that. When we took it to Chelsea and put it on the top of the pavilion, of course, it doesn't recognise the environment anymore. So you were getting false positives and seeing flowers. Because actually, when you think about it, those daisies that we saw. Let me see if I can go back to that slideshow now. Hold on. Hello, come on. There we go. So if I go back a little bit here, Those daisies, although they're a bit hard to see, they've got a darker center and a lighter outside, which can kind of mimic the body of an insect in its wings. So that would be one of the things. It's kind of the last thing you want, isn't it? Is to get false positives of the flower rather than the bee. And there's more flowers in there than bees. So it takes quite a while for you to train it to not do that, and you kind of need the flower itself that you're looking at. So Tom gave me one of those flowers to take with me. I took it home and then recorded a bunch of the insects on that exact flower and took it back, and it worked quite well after that. So that was all quite cool. And we're nearing the end of the talk. This was difficult because from a programmer's perspective, who's used to just sitting in an office like this and fixing problems, we were on site in amongst all of that building work that you saw on one of the previous slides. Not only this, interestingly, there's a bunch of London trees, what are they? London plains trees, they're called, and they give off pollen which is spiky, and it gets down the back of your throat and it makes everybody cough. And COVID is still relatively fresh in people's minds still, and everybody coughing is not good. But it's called the Chelsea cough, and everybody suffers from it. It's horrible, actually. You just need to keep drinking water the whole time. Probably you get a day and you're all right after that. Certainly, as somebody who's asthmatic and got hay fever and that sort of stuff, it's not the best environment. So dealing with all of that makes it you're kind of difficult to operate in that environment. You have to be really sensitive to the fact that you're getting in the way of people building a garden out there as well. So not treading on things, not getting in people's ways is really important, but not something that us tech folk are that used to. On top of that, internally for the project, we found that it was difficult to find people. Again, not a great deal of IoT in the UK, so finding people that A could do it and B were not on a project was quite difficult. And again, me myself, I was taken in and out of that because of the fact that I was needed elsewhere some of the time. So I was floating in and out. Luckily, I managed to be on that for a good long time towards the end. Otherwise, I think even then it would have been quite a struggle getting people to be able to go down and install all of the stuff, even that had the necessary skills to be able to do so. But nonetheless, fascinating. I mentioned earlier quite a lot of red tape internally. We had to get budget for this, even though this was from the top down, right from Paula Panara at the time to take us all the way down. We still had people pushing back on us on budgets to be able to do this. And you can't not buy things. You have to be able to do that. And you can't not pay people to go. But it was all internally funded. So between us and Microsoft. So it wasn't like it was a client project where the money was coming from outside. And it was chargeable as well. If everybody works in consultancy, for an internally funded project to be chargeable is unique. So getting over those hurdles was quite, well, I don't know, complex, shall we say. From my perspective, the lack of documentation I found tough, trying to retrain those models, and it was relatively new, so there wasn't much information or people I could ask even. And everything took lots of steps, and that's everything across the whole project. Of course, I get a microcosm of that retraining for us, but the whole thing, you had to go through a whole heap of steps to get it done. And under that as well, time pressure generally, because although we had actually the whole project was 2 years, we weren't full time until about 9 months before the build, and everything then takes time. And you realize that you just run out of it immediately, and then you get to site and you've got 2 weeks beforehand to get everything sorted. And we were still building stuff the night before we went live, so it was that tight. But great to be in that environment, and I work quite well under time pressure. It must be an ADHD thing, I think. So that worked okay for me in solving problems like that. But I think a lot of people found it quite stressful. It's not gone. This whole garden, or at least nearly all of it, is going to be installed outside Mayfield Park in Manchester. It's going to be right opposite the train station there. One of the first installs in that area in 50 years or something like that. So in collaboration with the council there, it will give this a place to go and live. But again, as I was explaining at the start, this has environmental and health benefits to do this. It's somewhere for folks to be able to go and chill out, and it's the environment should be good for that. And all of the technology, in theory, will go with it and carry on being instrumented and then drive further growth in this particular area, which is pretty cool. These are the links. I'll leave this on here for a bit in case folks want to take a screenshot or, in fact, a photo. I will be able to share a version of these without all of the videos in. They're too big. I think it's like 300 meg, this slideshow is. So no point me trying to share that. But I'll create a version without the videos for you. And so you'll get most of this to have a look at. But all of those links I showed earlier are on that screen there. So do, by all means, go and check that out. That's practically it. However, if you're interested in AI, do check out my videos. I've got some videos, don't go into all of this depth, but they do look at how we can set the Pi up and look at the AI camera and the AI kit. So you can scan that QR code there. I'll go to that bit.ly to have a look at that playlist all on YouTube. I'd love to get time to do this, but again, I'd be limited in what I could show without Avanade coming to my house and telling me off, probably. So hopefully in the future I'll be able to do that. Now, that is the end. Aside from, you really know you make it when your garden makes it onto Have I Got News for You? So if you've ever watched Have I Got News for You? It's a comedy news quiz, essentially, for the BBC. And we featured on that. So hopefully you'll be able to hear the sound, because I did select sound, but do shout if you can't.
Fingers on buzzers, teams.
Hello.
Yes.
That was very. It was a bit of nature and a hello. Is this the talking trees?
Yes.
There you go. So Chelsea Flower Show, because AI's everywhere now. It's even getting involved in nature, and they've connected trees up in a way that they can talk to you and tell you what they want. And mainly they just say, water!
I thought they'd done it because there's a royal visit and they've got to have someone for Charles to talk to.
12 trees have been fitted with sensors. Here's a sensor. It seems like it's been sort of hammered into the trunk.
Yes.
Yeah. Tree didn't like. They monitor the temperature in the soil.
Yeah.
And visitors can type questions to the tree and get a written answer about how they are.
Stop hammering fucking sensors into me!
You know, you can ask the trees questions remotely as well. We did.
Yeah.
Oh, yeah.
We asked a silver birch.
Yes.
The question, what do you think of Ian Hislop?
Oh, go on then.
Here's what we got back. It looks like there's been an issue with tree talk. Please try again later. What was the king showing off at the Chelsea Flower Show?
Juggling skills.
A new flower. The king.
So there you go. So that was really cool to see that. I mean, I love Have I Got News for You? I guess there'll be a few people on this call that like that show too. So I was just aimlessly watching the latest episode and it popped up, and yeah, it was really cool to do that. So I mean, you kind of you've made it when you've made it onto the BBC and Have I Got News for You? So yeah. So that was dead good. So thank you very much for watching. I've been Pete Gallagher. You can contact me at any of those things. So at Pete_Coes, you'll find me on X, if anybody still uses that, and Blue Sky. And then that's my personal website. And then if you want to email me, you can email me there at pete@pjgcreations.co.uk. And I'm happy to sort of take any questions that you've got now. But if you can't think of anything now, then do just drop questions. I love getting folks questions. Actually, a lot of the time it's, damn, I watched one of your talks and now I've gone and bankrupted myself by buying loads of sensors and stuff and having loads of fun that way. But nonetheless, I like to hear those stories. So thanks for listening, folks.
Thank you very much. So what was the reaction? Like, do you get a lot of people walking up to you and talking to you about how the garden was for them?
Well, good. I'm glad it's almost like we choreographed that. Well, one of the reactions was this. So we won gold.
Oh, yes.
So actually we won double gold at the Chelsea Flower Show. So we won gold so each garden can get a gold medal. So it's not like the Japanese garden won best garden, but it's essentially you propose what your garden will do. And then if it does everything and the judges think it does everything that it does, you can win a gold medal. So it does feel a little bit like a participation award, but it's not really like that, because you can imagine the strictness of the judging that's done here. So, and it's interesting because they come during the day, there's a judging day, and they walk around the garden and they take notes. No one's allowed to be there aside from Tom Massey and Jay on. They were the only people allowed to be there for that. and then they leave. And then you come back in the morning and there's a little stand in the ground and you find your gold certificate in it. So this isn't the actual gold certificate. You can imagine they're not going to let me have this. But every one of us got one of these replica certificates, which was nice. I've got a photo of myself holding the real one, which was quite cool nonetheless. So we got the gold for the garden, but also the best construction award. So we won that, which was nice. So double gold winning, which was really cool. The reaction was fascinating because I installed all of the garden, and then on show week I was speaking at NBC Oslo, so I had to go over there for most of that week. But I flew back on the Friday night and did the final Saturday, teardown day, really. But they have a day that's a lot cheaper for folks to come in, so you got a lot more of the public coming in, and they loved it. They found it really interesting, and they were asking lots and lots of questions. And then, as I say, it was teardown day, and at the end, you get to take bits. So I was able to take a bunch of flowers from the garden, and inside that pavilion on the left-hand side was loads of mushrooms growing, edible ones that I'd never even seen or tasted before, and they gave me a bunch of them. So here's me on the tube carrying a load of flowers in bags and these weird-looking mushrooms. And if you've ever watched The Last of Us, that TV series with the things that are growing out of people's heads, some of them looked like that. So I was stood next to a couple of women and they were asking me all sorts of questions on it, and they were fascinated, and they'd been to the Chelsea Flower Show. And it was really interesting. We gave away some bits as well. So this packet here, which of course I've taken one home in, contains seeds for some of the stuff in the garden. So we were giving people them as well, which helped. And also, now folks have got bits that are growing in their garden that was created as a result of what we were doing then in the Chelsea Flower Show. So I don't think we had across all, there was about maybe 10 of us across that week manning the garden, if you will. Terrible use of phrasing, but we were wandering around with those screens and speaking to people, and I don't think we had a single person who complained about our use of technology. The way it was done was done in a really caring way, and you could barely tell it. If you weren't looking for it, you could hardly tell it was there. So I think that really did help in the way we were doing it. The press coverage of it was generally all positive as well. Funny in the case of Have I Got News for You, of course. In fact, that generated conversation internally around that result, because that's an error that shouldn't have happened. So we were wondering what actually caused that, and it took people actually diving back into the code and making sure that it was working. Nonetheless, that was interesting. And yeah, quite a few horticulturists interested in the tech, but also quite a few geeks who are in there wanting to know what they could do for their fields and gardens. We had the head of trees from City of London come, which I never knew was a job. But how about that for a job? Head of trees. And his job was planting the trees in and around London. And he was telling us about how difficult that was. And then we ended up talking to him, and there's projects ongoing for that now as well. So all of the different people that you end up speaking to in all different walks of life was really interesting.
Very cool. Any other questions? So Tony, you worked on something with a.
Yeah, it was similar to instead of using soil moisture, I was looking at the leaves with infrared cameras. So the idea was that a plant's transpiring, the temperature of the leaf is below air temperature. But if it's not transpiring, the sun temperature raises the leaf temperature
Right.
by about 0.3 degrees.
So you have a camera focused on a leaf and then
Yeah.
figure out the temperature.
We take a snapshot every 20 minutes and transmit that back by LoRa and make an inference about soil moisture.
There's quite a few.
An inference about the amount of moisture in the plant.
Yeah.
That was better than doing the soil.
Yes, because you don't know the connection between the soil and the roots and the amount of water uptake by the roots. You don't know where the roots are. You don't know the amount of
The soil moisture sensor, you can push it down to where the roots are though.
yes.
We still don't know how efficiently it's getting to the leaves, though.
Yeah, and if it's not thriving in that environment, it won't be taking the nutrients or the water from that soil, even though it might have it in it. That's really cool. Was it infrared or something pointed at it, and it was using that
Infrared,
somehow? Yeah. Okay, so that's cool.
It's essentially the same sensors used for a non-contact measuring people, medical non-contact. and you trap that with the sun. So you use the sun as one of your heating sources.
So that's quite a few years ago, wasn't it? That was
Yeah.
it's like six years ago or something.
Soil moisture probes. The capacity ones below 50 megahertz, they're actually measuring soil moisture and salinity.
Oh, right.
So you can't compare one to the next, because you've got to calibrate each one on each side,
Right.
assuming the salinity is not changing, or the salts in the soil. Whereas above 50 megahertz, the thing is truly measuring. You can separate out, measure moisture content and soil salinity, or
Right.
nutrients in the soil.
And this was for a winemaker or
This
something.
was in one of the premium vineyards in Australia.
Same as for soil moisture. Why would make this going to Jason just an analog voltage that comes out of it?
Yeah, but it's generated. The capacity ones are actually generated by an AC RF signal. So that's what you're doing. So
Yeah, there's two different sorts, isn't there? The soil moisture sensors. One's capacitive, and there's another one inductive, I think. And they require a different mode of operation between those two. I think ours were capacitive, as far as I remember.
It's a photo.
we found the most dangerous thing in the vineyard was the pruning machines, and they'd forget to take them out of the vineyard. It's smashed things to bits.
All right.
Damn.
It could work out whether they went offline.
Yeah.
But it's quite away from your house, right? So you'd have to like drive.
Oh, it was a 400-kilometre drive to the vineyard.
Oh, wow.
So
Yeah.
no, you didn't want to go there too often.
Just for
So
the wine.
say Peter's got his hand up. Go ahead, Peter.
Hello, I had a couple of questions on sensors. One is to measure the soil pH. It's likely to change very slowly, so you could just plonk in your device and measure it, take it out, maybe do it once a week, and find that even that isn't necessary.
Yep, I agree.
The other is temperature and humidity will depend very much on where in the tree you are measuring it.
Yep, that's also true. What was interesting as well is that all of these trees aren't in Chelsea, and this is kind of how the sausage is made. They're not really planted in the garden.
Yes.
Because you want to save the tree, you don't want to destroy the tree, so you can't really do that anyway. They're actually they're bundled at the bottom. I forget what they call the bundle now, but all of the roots are just in a bundle with all of the nutrients they need, and that is planted, and then all of the soil's put around that essentially, often in a pot actually to keep it stable. And then they just uproot the whole thing, and by uproot I mean they remove the whole thing, bundle included, and then they can take it elsewhere. So actually sticking the soil sensor in was pointless because it wasn't touching the soil, that the tree was touching itself. But really, of course, what we're talking about here is a proof of concept. So in reality, you would measure this over longer periods of time, and then it would become useful at that stage. Now, if you imagine you are the head of trees for the City of London, you probably wouldn't want to have to pay somebody to go around and do that. And sometimes these things are concreted in so far that actually getting to the soil where the roots are is hard. So I think having some mechanism to be able to do that remotely would probably be what you'd want to be able to do. We wouldn't want to do it the way we did it there. We did it on a shoestring. So you'd go and buy these off the shelf, and likely it would be LoRa across all of that. So the tech would likely change under the hood, but the idea nonetheless would stay as it was. And you're right, temperature and humidity, but that's important. Probably more important to do that up front beforehand, because if you're going to put it in a shady area, you want to know what that shade looks like and how little rain it gets, perhaps, before then you make a decision on what tree should go in that location to suit that environment. So, yeah. Interesting, but of course having a advance notice of that you've made a bad choice can be useful as well, because perhaps you can pivot or do something differently, knock the top off a church or something. What's the best picture format to use? I was using PNGs there. to go in, and 600 by 600 as well. I think that was what the camera res was set to for the best compromise between speed and quality. I did have it at full HD at one point, but it just wasn't producing the results I wanted because that's not what I was using on the camera. So I kind of matched those two things together. So yeah, I've got a whole heap of training data. Even in that training data, there was nearly 700 images that I'd collated along the way. I made a little application that would take a video and then take time slices out of it for the images. And you, as you point out, it's images you're training on here rather than videos. So you need those in a particular format. Smaller the better generally, otherwise your data set's just going to be too big and you've got to store these things somewhere apart from anything. But you're wasting a lot of data if you have too high a resolution. So yeah.
What was the
Any other
general? Yeah, what was the general feeling of the team? Like, does everyone want to do a similar project in the future, or was it sort of something they?
And so it's still going. So we've got something internally called Project Bloom now off the back of this. So there was £175 million worth of what they call pipeline out of the back of this. So during those 7 days and then the days either side of that, we'd had quite a few clients or future clients come to see us. Of course, again, marketing exercise for the most part. But we had, obviously I mentioned the City of London, but also, interestingly, you mentioned it, vineyards approach us. So what you can't do there is screw a tree tag into a vine because A, it's not going to work, and B, it's not the environment, and C, who wants to screw a tree tag into a perfectly good vine. So more work required, but it's very chicken and the egg this is, because of course it's relatively new POC for everything we did and the way we did it, and it was quite targeted in the way we did it. So lots of different things we could do, but none of them which would be identical to what we're already doing. So the clients are generally looking for a fully built, fully designed, fully functional system, but that doesn't exist. So you have to find the right clients to be able to come along on that journey and fund that journey. But of course, we want to sell it to more than one person, so it makes it complicated to try and do. I'm not involved in part of that sales process, but nonetheless, I'm involved in the steering group for Project Bloom to try and help with the tech aspects of that and understand how we can leverage what we've created to hopefully drive sales, I guess.
Sounds like fun.
It is, yeah. I mean, this is by far the most fun project that I've done at Avanade. I've been there for nearly 4 years. And this stands out as being the most unique, certainly the one that I'll mention as the thing that I've enjoyed the most at Avanade. It was very tough, very interesting for the reasons I've explained, but it was fascinating and unique.
Yeah. And do you have any, you mentioned you're a STEM ambassador or involved in STEM. Do you have kids come up to you and sort of talk to you about it and what you said?
No, there's not. Although it got lots of coverage, it didn't really leak too much into the public consciousness. So I don't get a great deal there. Interestingly, at the Chelsea Flower Show on one of the pre-days, they invited a school along, and if you go and find it, there's a BBC Bite Size, I think, where they took some kids into the garden and they were letting them taste the leaves. You'll see the bit about the one that tastes like smoky bacon crisps, for instance. So they did involve some of the kids. I wasn't there that day. I was in Oslo at that time. But that looked like they had quite a lot of fun and there were some good questions being asked. So we tried to do that from our angle. But it's certainly one of the things that I mention when I'm doing any of my STEM ambassador engagements for when they ask me what cool stuff I've done. Yeah. I can't compete with the guy that sits there and tells me about when he went to Antarctica and he was counting penguins. But, nonetheless, talking to trees was quite fun.
Cool. Any other questions in the room? Great, thanks a lot, Peter. That was really very interesting. Sounds like a lot of fun.
Thank you very much for having me.
Sounds like this was a very good day job.
Yes, yeah, that certainly was. I'm working for the Irish Power Board at the moment, and it's web app based, and it's nowhere near as interesting as this. It's interesting, but in a different way. So this is unique. So I love talking about it.
Cool. Yeah, thanks very much. So we're just